Hello, guys. Welcome to Remta Solutions. Welcome to your lesson on organic molecules. Today's lesson is Introduction. It's going to be a lengthy one, but I hope it'll be worth it. So, let's see. In this video, we're going to discuss what are organic molecules. Secondly, what are the properties of carbon? You will understand why we specifically talking of carbon, and this you will understand from the first point of what are organic molecules. Thirdly, we're going to represent organic molecules. We're going to show you how organic molecules are represented. Fourthly, we're going to look at the prefixes used in organic molecules. Then look at functional groups and the homologous series. We will conclude this video with saturated and unsaturated hydrocarbons. Okay? All right. So, what are organic molecules? One thing I can tell you is that everywhere around us, including where you are seated, guys, there are organic molecules around you, even around myself, of course. All right, there are organic molecules around us. Now, when we talk of organic molecules, there's a study, a branch in chemistry that specifically deals with organic molecules, and that we call organic chemistry. So that is the branch of chemistry that studies organic molecules. But what are these organic molecules? They are molecules that contain carbon atoms, and these carbon atoms, not just carbon atoms, these carbon atoms are bonded with other carbon atoms as well as hydrogen atoms. Okay. Remember, the reason we are emphasizing that it is just not carbon atoms, it's because you can make a mistake and say these, for example, your carbon dioxide, carbon monoxide, carbonides, and stuff. You can make a mistake and say they are organic molecules. They are not. Organic molecules are carbon atoms that are bonded to other carbon atoms as well as hydrogen atoms. They may also contain oxygen, nitrogen, and even halogens. All right, remember halogens are your group 17 elements or atoms, right? Perfect. Now, remember, I said to you, everywhere around you, including where you are seated, there is organic chemistry in place. Even the food that you ate, there is organic chemistry in place. So, for example, let's look at all these items. Your food flavoring, right? Your food flavoring. This is caramel flavor, vanilla essence, all these flavoring that you find for your food. That's organic molecules in place. Your perfumes, methylated spirit, your gas, your clothes. Oh, I see we also mentioned bananas. Guys, don't worry, we are not going to look at all of them individually, but all these items have organic molecules in them. Okay, even in medicine, medicine uses organic molecules. Okay, your oil refinery, that's organic molecules. You are going to understand these things, guys, at the end of our series. For now, as this is introduction, let's not get deeper into it. All right. So, remember that organic molecules, I said to you, even the food that you ate has organic molecules. Nature on its own has organic molecules, okay, has organic compounds. For example, your fossil fuels, where we get our oil, where we get our coal, those are organic compounds, okay? And some organic compounds, guys, are synthetic. For example, the material that we use to make clothes, polyester, for example. Okay, and remember, where do you find your carbon, for example? You know, carbon is found in nature. Where do you find it? You can find it normally in the atmosphere. It is abundant as carbon dioxide. All right. You can also find it in your coal, your petroleum, your natural gas. You see, you can find it there. Okay, but let's not look at that for now. So let's look at carbon. We said to you organic compounds are molecules that contain carbon atoms that are bonded to other carbon atoms as well as hydrogen atoms. All right. So properties of carbon. What makes this carbon special? You know, guys, that carbon, it is not just that element in the periodic table. Remember, even your periodic table has is using this carbon. Most of your, not most, your relative atomic mass is made subject to or relative to carbon. So carbon has huge application in chemistry. All right. So not only is it that molecule in group 14, or what do we call it? Not only is it that element number 6 in the periodic table, all right, but it being element number 6, meaning in group 14 or group 4, it can donate and accept electrons, isn't it? Oh, yeah, that's how special it is. But not only that, um, this carbon, remember we said it can form bonds with other carbon atoms and atoms such as oxygen, hydrogen, nitrogen, and halogens. All right, so these are your organic compounds. Okay, these are your organic compounds. Okay, these are your organic compounds. Okay, guys, perfect. Now, another property of carbon that is special is this: carbon can form with other carbon atoms, can form single bonds, triple bonds, or double bonds with other carbon atoms. Okay, this is what makes it special. It can form single bonds, it can form double bonds, or it can form triple bonds with other carbon atoms. Okay, perfect. Now, another thing that you also need to know is this thing here, is that carbon, you see, it's a special atom or it's a special element. It can form straight chains, branched chains, or it can even form cyclic molecules. But for your syllabus, we are not going to look at your cyclic molecules, okay? We're not looking at cyclic molecules. For example, your benzene, we're not looking at that, okay, guys? Perfect. Now, one thing of carbon that you know is that, remember we said it can form, as a reminder, it can form straight chains, branched chains, or cyclic molecules. Now, this is because it has the ability to form long chains. Right? It has the ability to form long chains, and that we term catenation. Okay, we term it catenation. All right. Now, what is this? This is basically how atoms can uh, form bonds of the same elements into longer chains. You will see that as we progress with organic molecules, that you will find that some molecules have 2 carbons, some have 20, some have infinite number of carbons, right? But for your grade 12 syllabus, you are subjected to just a maximum of 8 long chain carbons. Okay, we are subjected to 8. There can be substituents in the process, but the longest chain will be 8. Okay, but you're going to see that. Okay, you're going to see that later. All right. Then, so being a chain, it doesn't mean that the chains could just be straight chains. They can be branched or they can be straight. By straight we mean unbranched. Okay, they can be like that, but this you're going to see later. All right. Now, I want us to look at the types of carbon. Our carbons, you will find that you have primary carbons, secondary carbons, tertiary carbons. This you will find more useful. This you will find more useful when you get to homologous series that we call alcohols. Okay, you will find more useful when you get to a homologous series that we call alcohols. But for now, I have to introduce this. So, what are primary carbons? A primary carbon is a carbon that is bonded to only one other atom. For example, let's look at this molecule here. Let's look at this molecule here. Okay, let's look at this molecule here. Um, Maybe let me erase one. I'm going to erase this. Let me erase this. Okay. So this molecule that I just drew here, we call it ethane. Okay. We call it ethane. Each and every carbon here is a primary carbon. It is bonded to only one carbon. If you look at this carbon, it is only bonded to one carbon. Even this one is bonded to only one carbon. Now let's look at secondary. Secondary is bonded to two other carbons. So I'm going to highlight whichever is secondary. Okay. So look at this one here. So I'm going to highlight whichever that is secondary. Okay, I'm going to highlight whichever that is secondary. This one, we call it propane. You're going to get to know these things later, guys. All right. So one that is a secondary carbon is this one here. Why? It is bonded to two other carbons. Okay. It is bonded to two other carbons. Okay. It is bonded to two other carbons, right? Okay. This one to two other carbons. Now, with tertiary carbons, it is bonded to three other carbons. Okay, it is bonded to three other carbons. Now, I'm going to show you an example. An example of our tertiary carbon. Let me try this one here. Let me try this one here. I'm going to show you which one is tertiary. I'm going to highlight a tertiary carbon. Okay. I'm going to highlight the tertiary carbon. Can you see it? It's this one here. Oh, no. I forgot to add another carbon here. Okay, but it's still the same. Oh no, it's still the same. I just want to add the carbon. So to make it tertiary, come on, buddy, change the color. So do you see this? Can you guys see this? Look at this. It is indeed tertiary. Do you see? It's bonded to one, two, three other carbons. So this carbon is tertiary. For example, now let's look at these ones. This one is primary. This one is secondary. Right? This one is primary. This one is primary. This one is tertiary. This one is primary. And this one also is primary. Can you see that? And these are the way that your carbons are bonded, the types of carbons. Okay, these are the types of carbons. All right, perfect. Now we have four ways in which we represent. Our organic molecules. Those ways are your structural formula, semi-structural formula, condensed structural formula, and the molecular formula. I'm going to give you structures, for example, examples of each. So let's begin. With the structural formula, it shows every bond between every atom in the molecule. I'm going to give you an example. Okay, I'm going to give you an example. I'm going to give you an example. I'm not going to give you a name of this molecule. For now, the names are not important. Okay? For now, the names are not important. But in case you want to know, this one is called 2-methyl. Okay? It's called 2-methyl propane. You're going to understand this later, but for now, it's not important. So remember, structural formula, it shows every bond between every atom. Can you see this? Look at this. The bond between carbon and hydrogens are shown. The bonds between carbon and carbon are shown. This is a structural formula. Okay, perfect. Now, let's now go to semi-structural formula. This shows only carbon-carbon bonds and does not show carbon-hydrogen bonds. Continuing with 2-methyl propane. Remember, let me show you the structural formula. If you remember, it was something like this. Oh, come on, buddy. I went too high. All right, okay. It's fine. So I'm just showing you the structural formula. Okay. Come on, come on, come on. It's not a double bond, okay? Okay, so you see now, this is a structural formula. Now a condensed structural formula will show the bonds between what? Between carbons. So it'll be CH3 for this carbon here. As you can see, it is bonded to 3 hydrogens. Show the bond. The carbon in the middle, it's bonded to only 1 hydrogen. It's then bonded to another carbon, which is this one here. And this one is bonded to 3 hydrogen atoms. And then this one here is bonded to 3 hydrogen atoms. Do you see this? This is your semi-structural formula. Remember, semi-structural formula does not show carbon-hydrogen bonds. It's only showing carbon-carbon bonds. Okay, and this is your semi-structural formula. Okay, great. Now, let's go to the third one. And by the way, before I go there, guys, remember, maybe, since it's introduction, you don't remember. Inorganic molecules, sometimes your hydrogen atoms can be replaced. When they are replaced, there can be another atom added, being it hydroxyl, can be oxygen, it can be nitrogen, it can be a halogen, and so on, or it can be what we call alkyl substituents, right? It can be what we call alkyl substituents. Okay, so those are what we call substituents. Substituents are basically atoms that replace a hydrogen in your organic molecule. Okay, it doesn't necessarily need to be one substituent. There can be more than one substituent. Okay, there can be more than one substituent. Okay, all right, I needed to add on this. So for example, with this one, normally, for example, with this one, we call it 2-methyl propane. Normally, in place of this third carbon, there was a hydrogen, or fourth carbon here, there was a hydrogen. So we replaced that hydrogen with CH3. CH3, we call it methyl. Okay, but for now, don't stress about it. You're going to get it later. Okay, substituents, you're going to see them later. Okay, all right. Now let's look at condensed structural formulas. Okay, let's look at condensed structural formulas. Now, these ones do not show any bonds between atoms. I'm going to start again with our structural formula. Okay, I'm going to start with our structural formula. Okay, I'm going to start with our structural formula. Okay, so this is our structural formula. So now what we need, let's look at the first carbon. It is bonded to how many hydrogens? 3 hydrogens. The second carbon, it is bonded to 1 hydrogen, and not just 1 hydrogen. In addition, it has a substituent. Now that substituent, we open a bracket, it is a substituent CH3, which we call methyl. Okay, the third carbon, it is bonded to 3 hydrogens. I repeat, the first carbon is bonded to 3 hydrogens. Here is it. The second carbon, which is the carbon in the middle, it is bonded to 1 hydrogen and a substituent CH3. Here is it. The one here on the right, which is the third, is bonded to 3 hydrogens. And this is your condensed structural formula. Okay, this is a condensed structural formula. Okay, perfect. Now, molecular formula, it only shows the number of atoms of each element that makes up the molecule. Again, let me draw the structural formula of our molecule. Remember, I said it is 2-methyl propane, right? It is 2-methyl propane. Guys, I know it's tiring to be writing these H's. So let's ask ourselves, how many carbons do we have here? We have 3 carbons. How many hydrogens do we have? 3, 6, 9. Right? We have 10. Do we have 3 carbons? No, we have 4, man. Come on, buddy. We have 4. Right? We have 4. So we have 4. Right? We have 4 carbons and 3 and 10 hydrogens. Right? And 10 hydrogens. Isn't it? What does this look like? You'll understand this. It has an isomer, guys. Okay, it has an isomer, but let me not talk about it for now. These are some of the things that you're going to see later. So this is the molecular formula of 2-methyl propane. Okay, this is the molecular formula of 2-methyl propane. Okay, guys. All right. Okay, so we're done with representing organic molecules. So there are prefixes that we use in organic molecules. Those prefixes, they are determined by, guys, remember, it's not merely the number of carbon atoms. And then you say, oh, there are 4 carbon atoms, therefore you are meth. Or if there are 4, okay, you are but. Or if there are 3, you are prop. If there are 4, you are F. You are going to see more on this. But they are like that because we're referring to something that we call the longest chain. Okay, the longest chain. So if your longest chain has 1 carbon, your prefix will be meth. If it has 2, it'll be F. If it's 3, prop. 4, but. 5, pent. I know you guys know pent, hex, hept, oct. Right? So with you guys, your longest chain is 8. So you are going to use these prefixes. Even with your alkyl substituents, you're gonna see that. But for now, we are not talking about that. Just for you to know these prefixes. Remember, 1 is meth, 2 carbon atoms, longest chain, it's F, 3, it's prop, 4, it's but, 5, pent, 6, hex, 7, hept, 8, oct. Okay, all right. Now, we're going to discuss a functional group. A functional group. Okay, let's not get into the English of hey, functional group, but it is like that even in English. So it's a functional group. It's a working group, isn't it? It's a working group. A functional group is a working group. Now, check what we say in chemistry. It is an atom or atoms that determine the physical and chemical properties of a group of organic compounds. Okay. It is an atom or atoms that determine the physical and chemical properties of a group of organic compounds. So, what we are saying is that we are saying that a functional group is basically the center of reactivity of your organic molecules. So basically, um, every, I'm going to call it homologous series, but you're going to see what is that later. Every organic group of organic compounds that behave the same, say they have the same name, for example, alkanes, which we call propane, methane, blah, 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 will undergo the very same chemical processes, regardless of the size of their molecules. Right. So now when we talk of functional group, basically here we're talking of the center of reactivity of the molecule. Okay. So a functional group, someone would say it is basically it's a group of atoms that form a compound, and how they are bonded will determine how the compound reacts. Okay. All right. Now let's proceed. So remember I said it is a center of reactivity in an organic molecule. All right. Now another thing that I want you to know, a functional group, I mentioned this, will undergo the same chemical processes regardless of their size. Now, you have seen when I've been writing some organic molecules with single arrows in between, but I did say carbon can have a single bond, a double bond, or a triple bond, right? So this is why we're saying molecules can have more than one functional group. Okay, molecules can have more than one functional groups. You're going to see examples of functional groups later. But remember, a functional group is an atom or group of atoms that determine the physical and chemical properties of a group of organic compounds. Okay? All right. All right. So then let's look at this homologous series. I've been talking about homologous series forever. Now, this homologous series, ooh, interesting. Now, this homologous series, it is a series of compounds with the same general formula. If you hear this, guys, I need to highlight this. Group of compounds with the same general formula or functional group. Okay? Group of compounds with the same general formula or functional group. Are you guys following? That is a homologous series. So, the homologous series that we're going to look at for your grade 12 physical sciences organic molecules are the following. They are 9 in fact, not 6, 9. Back then we used to deal with about 12. Yeah, there was about 12 that we dealt with, but right now you guys deal with 9, which is okay. So they are alkanes, alkenes, alkynes, alkanes. These we call them alkyl halides, alcohols, aldehydes, ketones, carboxylic. Oh my. This is supposed to be C. So it's supposed to be carboxylic acids, and 10 esters. You are going to understand all of these, guys. So in other words, you are expecting a minimum of 9 more videos in addition to this one. There's a video that will be dedicated to each and every one of them. So 9 videos to look at these. And I can assure you, for this topic, we will have about 12 videos dedicated to organic molecules, just teaching. Okay? So remember, it's a series of compounds with the same general formula or functional group. Okay? All right. Now let's summarize this. Now the homologous series that we call alkane, its functional group is a single carbon-carbon bond. It's something like this. It looks like this. Let me use a black color. I prefer black here. Single bonds are like this, isn't it? Single bonds are like this. Can you see that? So these ones are where your hydrogens are. All right. Now, alkenes, its functional group is at least one double carbon-carbon bond. So in other words, they can be like this. Okay. Remember, guys, they can have more than one double bond. Okay. So at least, I'm saying at least one double carbon-carbon bond. Then we go to alkynes. Its functional group is at least one triple carbon-carbon bond. So carbon triple bond. Now, do you see those properties of carbon? Do you see them now? Look at that. It can form a single, double, or triple bond with other carbon atoms. Can you see that? Now we have haloalkanes. All right. Now we have haloalkanes. Haloalkanes, they are single carbon-carbon bond with a halogen. These ones we normally refer them to, we draw them like this, where this X represents a halogen. Remember, halogen are group 17 atoms. Okay, halogens are group 17 atoms. All right, so this is your haloalkane. Remember, haloalkane functional group is a single carbon-carbon bond with a halogen, as you can see. Right, so you can basically expect it to be like this, where this R is your let me call it alkyl, but because I haven't yet covered alkyl, alkyl is your CH3, CH2, CH3, CH2, CH2, CH2 until CH3. Okay? All right. But you're going to understand this later. For now, don't stress much about it. Okay, guys? So even if you don't write the R, it's okay. Now let's look at an alcohol. An alcohol is its functional group is a single carbon-carbon bond with a hydroxyl. So for example, you have something like this, and then you have this guy here. This is what you call your hydroxyl, right? This is what you call your hydroxyl, right? This is what you call your hydroxyl. I know you know it as OH minus, right? This is what you call your hydroxyl. So when you see an organic molecule with OH like this, you must know it's an alcohol. Okay, but hold on. Some are really complex. Okay, some are really complex. But remember, this is just introductory video. You're going to understand them later. All right, perfect. Now we then look at aldehyde. Now with the aldehyde, its functional group, it's a carbonyl group. So a carbonyl group, guys, we normally look at it like this. It looks like this. Okay, it looks like this. So now with this one, it'll be a carbonyl group. So I want you to see it like this, and then you can see it'll have an H, and then the longest chain will be extending. Remember, it doesn't mean that the H must always be to the right. It can also be to the left, and the molecule extends to the left. Okay, so this is how you will spot a aldehyde. A ketone, it'll be a carbonyl group extending on both sides. So it'll be like this. One side is extending, and then another side will also be extending. The reason I'm writing the R prime is to say the R's do not necessarily need to be similar. Okay, the R's do not necessarily need to be similar. Okay, guys. Then we look at a carboxylic acid. A carboxylic acid basically has a carboxyl group. Carboxyl group is what we call COOH. Let me not write it here. Carboxyl group is what we call COOH. Okay, is our COOH. You guys will see it just now. Maybe let me draw it here. I have space. It's like this. Okay, this is a carboxylic group, a carboxyl group. Okay, now carboxylic acids, you will see them like this. It is a carboxylic group, right? And then the molecule extends. Remember, it doesn't necessarily need to be on the OH does not necessarily need to be on the left, on the right. It can also be on the left and the molecule extends to the right, or it can be here on the right and the molecule extends to the left. And ester, it's a bit complex. So yeah, it's a bit complex, but it does contain a carboxylic acid and an alcohol. Okay, it does contain a carboxylic acid and an alcohol. But you are going to see this. So I'm not going to show a structure of an ester as yet. You're going to see this later. Okay, you're going to see this later. All right, guys? Then let's look at saturated and unsaturated hydrocarbons. I see a key word here, hydrocarbons. What is this hydrocarbon? You must think of it, guys. Hydro. I know with me, whenever I see hydro, I think of water, I think of hydrogen, but hydrocarbon. Do I have to think of water and carbons? I don't know. Or hydrogen and carbons? I don't know. But let's see. What are they? Hydrocarbons. They are organic molecules which contain only carbon and hydrogen atoms with no other functional group except the single, double, or triple carbon-carbon bonds. Are you guys hearing me? Organic molecule which contain only carbon and hydrogen atom. Okay? Only carbon and hydrogen atoms with no other functional groups except the single, double, or triple carbon-carbon bonds. You guys see this? Oh yeah. Now, saturated hydrocarbons and unsaturated hydrocarbons. What are these? For you to say a hydrocarbon is saturated, it will contain only single carbon-carbon bond. And if it is unsaturated, it will contain one or more double or triple carbon-carbon bond. Remember I said a molecule doesn't necessarily need to have one double bond or one triple bond. It can have more than one double or triple bond. Okay? Oh, yeah. So these are the differences. Remember, unsaturated contains one or more double or triple carbon bonds. Okay? Oh, yeah. Now, with that being said, we have come to the end of our video. And re bue jaana ka Setswana re a leboga, nga Tshivenda ro leboha, and then in Xhosa enkosi, in Swahili asante, in English thank you. The next video that you are going to watch, that we are going to upload, is on alkanes. Okay, the next video that we're going to upload is on alkanes. So stay tuned, guys. And remember, if you would like to keep in touch with us, visit our website www.aramtasolutions.co.za. Now, in the description of this video, all these icons, the links to all these social media platforms are given in the description of this video, including on WhatsApp. And so is if you want a tutor. So with that being said, ours ends here. Stay tuned to our video on alkanes. Now let the games begin. And bye-bye.